Okay, so we're going to have a look at how we differentiate an exponential function. So here we have y is equal to e to the power of 6x. Now, if you're looking at page 25 of your log tables, you'll notice that when you differentiate e to the power of x, you actually get e to the power of x. Now, in this case, it's not just x, so I'm going to start off and do my usual. I'm going to let u is equal to 6x. So y is equal to e to the u, and u, remember, is 6x. So I do dy du. Now, when I differentiate e to the power of x, I get e to the power of x. So when I differentiate e to the power of u, I get e to the power of u. So it's the same. And then du dx is 6. So my usual then, if I multiply dy du by du dx, the du's cancel, and I'm left with dy dx. So to get my answer, I just piece the two together. So 6 times e to the u. And then to finish the question, I just sub back in for u, which is 6x. So that's my final answer for that differentiation. Okay, let's do that again. So for this one, I notice again, it's not just x. So I let u is equal to x squared. So y is equal to 5 times e to the power of u, and u is x squared. So I do dy du. Now 5 is just 5. Remember, the number remains. And when I differentiate e to the u, it stays as e to the u. Du dx becomes 2x, and then I piece it back together, multiply the two together to get dy dx. So that's 10x, because it's 5 and 2x, 10x, e to the u. And therefore, my final answer is going to be 10x e to the x squared, because I replace back in the u. Okay, let's look at another one. So I let u equals to cos x. So y is equal to e to the u, and u is cos x. So if I do dy du, I simply get e to the power of u again. Du dx, so on page 25, I can see cos becomes minus sine x. And now I multiply the two together to get dy dx. So piecing it back together, I get minus sine x, and that's all times e to the u being cos of x. So it might be neater actually to write it as follows: minus e to the power of cos of x, and then times the sine of x. Okay, so that's that one. This next one, because it's only a 2 on top, it's not 2x. Okay, if it was 2x, it would be the quotient. But bearing in mind that it is just 2, I think a good place to start is just to move that into the top position, and therefore I change the sign of the power. And then I do what I normally do, let u equal to the power if it's not just x. So y is in fact 2 times e to the u, and u is minus 3x. So dy du is 2 e to the u, because e to the u differentiated is itself, and this becomes minus 3. So to piece it back together now, I just multiply them by each other. I might do it up here actually. So to get dy dx, I just multiply minus 3 times 2 e to the u. So really it becomes minus 6. So dy dx is minus 6 e to the power of, and then u is minus 3x. Returning it the way I found it, it's going to look like that. Dy dx. Okay. The next one. So when I look at this one, and if you think you're for yourself here, it has a power. So this one has to be chain. So I do my usual. If my y is equal to this, and I'm using my chain rule, then dy dx is going to be 4 to the front and reduce the power by 1. But don't forget, I have to differentiate what's in there. So if I differentiate that, now you can take it to one side if you wish. We might do that just for the first one anyway. But it's an easy enough one, because when you differentiate e to the x, you get e to the x. And when you differentiate 1, it goes to 0. So that ends up being e to the x. So piecing it together, 4 times e to the x, and then it's e to the x plus 1 cubed. And that is my derivative. Okay. The next one, find the value of dy dx at x is equal to pi over 4. Now this one is the product rule. How do I know it's a product? Because I have an x times an x. So u is going to be equal to the first part. Sorry, I should have written product there, so it's clear in my mind what we're doing. V is equal to the cos of 2x. So du dx. Now, when I go to do this, if you want, you can go and change the color of your pen, because really we need to deal with the fact that if this was a question on its own, we would normally let u is equal to 2x. So in other words, y would be e to the u and u would be 2x. So if I was doing this as a standalone question, my answer would become 2 times e to the u, which is 2x. So du dx is that. Now, if I'm doing dv dx, again, if I want to change the color of my pen and go off to the side, normally this thing, if I was doing this as a standalone question, I would let u is equal to 2x. So really, I would have y is equal to the cos of u, and u itself is 2x. So if I'm doing dy du, cos, according to my log tables, when you differentiate it, becomes minus sine of u, and du dx becomes 2. So piecing it back together and replacing back in the u, it becomes that. So that is my dv dx. Actually, I'll just draw an arrow there. So that itself is my dv dx. So now remember, the product rule is our overall rule. So dy dx, and the product rule tells me it's u times dv dx plus v times du dx. So my u is e to the power of 2x. My dv dx is my minus 2 sine 2x plus v times, which is cos 2x, times du dx, which is 2 e to the power of 2x. So if we tidy that up a little bit better, it looks like this. So it's better kind of to have the e to the front, really. And then the cos of 2x there.